Again, we're just trying to go through as many as you can. So if you think this is simple, right, try to go for speed. Okay, go as fast as you can and see if you can get the correct answer. But note that I noticed you guys still haven't really gotten the right answer the first time round. Okay, and you guys still somewhat relying on my answer to complete your answer. Alright, so don't delude yourself into thinking that you can do these questions yet. Okay, so in fact, you guys should actually go back, spend like half an hour, redo all of these questions as fast as you can. Right, and that's when you know you can actually do all the questions yourself, get to the right answer. All right, now question 6. I'll give you guys a bit of a head start and I'll start working through this one. Now, from now on, I will cut down on the number of steps that I will use. See if you can still follow. All right, I'll start going through these. Alright, technically it should have taken you guys only this long to do question 6A. Let's see how much you guys remember from a sine equation. Okay, so question A is very simple. Amplitude is 4 and the period is 2 pi over 2, which is pi. What does it mean by amplitude is only, the period is only pi? How many cycles are we sketching?
1.
1? 2.
2 is negative.
Yep. Okay, so note that you gotta try question B by yourself. I'll start working through it, but you need to find axis intercepts and the endpoints. Okay, and make sure when you draw it, you would have ultimately you should have 2 cycles. Okay, any question for the x-intercept?
I don't understand the domain.
The domain thing?
Oh, yeah.
Okay. Yeah, so the idea is that you need to let a equals to the to what's in the bracket here. Alright? And then you try to solve sine a equals to 0. So we need to find what values of a we need, how many answers there are. So we need to change up the domain. So the first part, this is the original domain, right? But what we want is the 2 times x plus pi on 6 domain. Okay, so you have to slowly do it one by one. So you normally do the one closest to x first. So you add it by add pi on 6 on every single side of the domain there, and then you would times each side of the domain by 2, and then you get here is the domain for a.
So where the two? Oh wait, no, okay.
Yeah.
I see what that.
Yeah, so we want this version because this version is a because we are solving for the angle a. Alright, but the domain that we got, original domain that we've got, is for x, not for a. So you need to change it to a, which is basically this thing here. Okay, this one you normally you would have to do the part that's closest to the x first, which is the, in this case is a plus pi on 6. Right? If you times 2 first and then you plus pi on 6, then that would be 2x, and then that would turn into like a 2x and then plus pi on 6 on the side, which is wrong. So that's why you have to do plus pi on 6 first, and then you times the whole thing by 2. Okay, so that's these are the steps here. So this one would be plus pi on 6 on everything, and from here to here you need to times 2 by everything, and then after that just simplify. Okay, does it make sense? You have to change up the domain because you're solving for a different variable. So you need to get the domain for that other variable. Any question, Emily?
Don't really understand.
Okay, I'll give you a slightly different explanation, Emily. So, okay, let's say this one here. All right, solve sine x, okay, equals to 0. And then the basic domain is from 0 to 2 pi. All right, then you would have 3 answers, which is 0, and then pi, and then 2 pi. Right? So x would be 0, pi, 2 pi. But if you're given a separate equation where sine of 2x equals to 0, right? But then the domain for x is 0 less than equals x less than equals 2 pi. So note that the idea is that we're solving for this entire thing. So initially you might think, oh, 2x could be either 0 pi or 2 pi again, right? But are these the only answers? Well, actually no, these are not the only answers, because if you're solving for 2x and you change up the domain, then 2x would actually be between 0 and 4 pi. So you can technically get 2 more answers for 2x, which are going to be 3 pi and 4 pi, right? And then when you divide everything by 2, the answer will be 0, pi on 2, 2 pi divided by 2, which is pi, and then 3 pi on 2, and then 4 pi divided by 2, which is 2 pi. So you see, if you solve for 2x, you need to get the domain for 2x, and then when you get the final answer, see, all these answers are between 0 and 2 pi for x. But if you only use the original domain, you only get the first 3 answers, which is not everything.
Oh.
Okay, so you have to change up the domain. So this is a simpler version of that same question. Okay, so at this point, to save a bit of time, if you guys haven't solved x-intercepts yet, just get the answers that I've got there, all right, and then see if you can calculate the start and end point and then sketch it. See if you can actually sketch it.
values of A that you got there.
Mm-hmm.
How did you how do you know where to start? Because the domain's it's really weird.
Good question. So the domain for A, right? Another step to you have to sort of modify it a little bit. This question is more complex than it initially looks. So this one, negative 5 pi on 3 is so note that this. Okay, so negative 5 pi on 3 is close to negative 2 pi, but it's not negative 2 pi, right? So note that negative 2 pi would be negative 6 pi on 3. So we haven't actually gotten there yet. And then 2 pi would be 6 pi on 3, right? So the domain is actually a little bit past 2 pi, but a little bit before negative 2 pi. Yeah, does it make sense? That's why you would go from 0 to pi, and we can get to 2 pi because that's 6 pi on 3. It's still within the domain. And then you can go backward one to negative pi because negative pi is still negative 3 pi on 3 It hasn't gone past the negative 5 pi, but you can't go to negative 2 pi because then that would go past the lowest domain.
So where do we start with the?
You start with the easiest one and you try to find the other angles, like yeah, okay. Let me record the explanation for how to solve for A. Right, this is what you're asking, right? So for A, and how do we know when to start given like a strange domain like that? Okay, so note that sin A equals to 0, so the possible values, right? The possible values would be on the positive region would be 0 pi, 2 pi, and then 3 pi, and then 4 pi, and so on, right? And then negative would be negative pi, negative 2 pi, negative 3 pi, and so on and so forth. So where do we stop? Where do we end? All right. So for the domain, so we're solving sin A, and then the domain is like two weird numbers here. Where do we stop? Where do we end? The idea is that you need to convert each of these numbers into over 3, right? Into something over 3. So the possible values would be 0 pi over 3, right? And then 1 pi, which is 3 pi, right? 3 pi over 3, and then because we're counting pi over 3s, so that'll be 6 pi over 3, and then 9 pi over 3. And in negative region would be negative 1 pi over 3, negative 2, negative 3 pi over 3. Let's say we go to these ones so far. Okay, right, makes sense so far? These are the possible values, right? These are the possible values of A. But where do we start? Where do we end? So note that once you've converted into like over 3 version, let's see, the start is negative 5 pi on 3. You can't go below that. Okay, it's negative 3, negative 4, and this one would be negative 5 pi on 3, right? So we take this value, and then in the positive region, you have to stop at 7 pi on 3. You have to stop over here.
Yeah.
Right, so this is how you know what the values are. So, right, so this is the domain for A. Right, make sense? Yeah. So you have to convert into the same denominator as the domain for from these possible values here. So this is like unit 2, but the complex familiar question, and now becomes a simple familiar question in unit 4. Not so simple. Right? So you have to go back and practice these ones, okay? And make sure you're able to calculate the start and the end points, and then sketch the graph for this one. Because so far we've only found the x-intercepts and then the y-intercepts. Okay, actually maybe just follow my explanation for now, okay, and go back and see if you can redo this question. This is a really complex, simple familiar question, really long one. Okay, endpoints. Let's see what the endpoints will be. So start point. Okay, so start point would be f at the lowest x value, which is negative pi. Okay, and that would be 4 sine of 2 times, I think, x plus pi on 6. And then x would be negative pi plus pi on 6. Okay, so this would be the start point. Okay, let's see. So 4 sine of that. So 4 sine, and then I will resolve these. So that will be negative 6 pi plus pi, which is negative 5 pi on 6. So that will be negative 5 pi on 3. Okay, make sense so far? Yeah? How do we deal with negative 5 pi on 3? Don't like dealing with negative. But sine of that is the same as when you do the same angle, but plus 2 pi. Does that make sense? Right? If you get a weird negative angle, just add 2 pi to it until you get a nice positive angle to work with. 2 pi again is 6 pi on 3, so that'll just be pi on 3. Okay? And pi on 3 is, once again, will be like this one here, and that would be square root 3 over 2. So that'll be 2 square root 3. Okay? And then the endpoint. The endpoint would be f of positive pi. Okay? And f of positive pi would be 4 sine of, again, 2 times positive pi plus pi on 6. So that'll be 7 pi on 6 or 7 pi over 3. So 4 sine of 7 pi over 3. How do we deal with sine 7 pi over 3?
You minus 2 pi?
You minus 2 pi, yes. You either add or minus 2 pi and the sine value is still the same. Any question, Emily? No. So you minus 2 pi. And 2 pi is just, 6 pi on 3. So that will be 4 sine of pi on 3 again. And that will be the exact same thing, which is 2 square root 3. Why do you think these two values are the same for start and end point in this question? Why?
Because
Yeah, Suleiman? Any guess?
because like the sine, it graphs like starts and ends on the x-axis.
No, they don't end on the x-axis. This means that the start point is higher than the x-axis. 2 square root 3, right? It's higher. Okay, let's do a bit of a recap. So summary. So far, what we've got is the y-intercept, right? What's y-intercept here? 2 square root 3. So y-intercept is 2 square root 3 and x-intercept. The following values here, negative 1, 2, 5, negative pi on 6. Yeah, I'll start with the lowest one, negative 4 pi on 6, negative 4 pi on 6, negative pi on 6, and then 2 pi on 6 and 5 pi on 6. Okay, and then we've got the start is the point negative, start is negative pi, and the y value is 2 square root 3, and then the end point, right, is positive pi, and the thing is also 2 square root 3. Okay. The actual explanation for why the start and end point is the same is because it's exactly 2 cycles. Okay? Same, cause exact 2 cycles. Remember, when you have a cycle of any trigonometric graph, it starts and ends at the same point, right? Even if you shift this a bit later, so let's say you start somewhere up here, right, and then you go down, and then you go up again. One exact cycle will start and end at the same point, right? But if you don't have a full cycle, if you have 2/3 of a cycle, then it must end at a different point, right? So if you have 2 full cycles, then let's say that's a cost graph, right? And then if you repeat another cycle, see it will start and end at the same point for 2 full cycles. Does that make sense? Yeah. So sometimes you can make the argument, oh, it's a full cycle, so it must start and end at the same point. You don't even need to calculate the end point. But to be safe, just calculate that anyway. Okay. So let's see how we will actually sketch this. Now note that the domain, the amplitude is 4. Right, so it goes all the way up to 4, and then the period is pi. So there'll be 2 cycles. We already showed that there are 2 cycles. Okay, let's see. It starts negative pi and ends at positive pi. How do we sketch this though? Let's say negative pi is here, and positive pi is here. Now, roughly 2 square root 3 is what value? Let's say this is 4 and this is negative 4. Roughly 2 square root 3 is what value? Any idea?
It's like 3 point something.
3 point something, yeah. 3 point something, right? So I'll choose the value here. So this would be roughly 2 square root 3. Okay, and that's also the y-intercept and also the endpoint. How do we mark out the x-intercept though? What do you think? How do we mark out the x-intercepts? Look at the denominator. What's the denominator?
6.
Oh, yeah, over 6, yes, which means in 1 pi, you chop that 6 times.
Yeah.
Does that make sense? So we 3 on each, I'll half it first, and then it will be 3 on each side, like 1, 2, 3, and then 1, 2, 3. Okay, does that make sense? Each tick is just pi over 6. Okay, so negative 4 pi over 6 is like here. If this is negative pi, which is negative 6 pi over 6. So then that will be negative 4 pi over 6 here, right? And then negative pi over 6 is here, right? Okay, and then after that would be 2 pi over 6, and then 5 pi over 6. So these are the x-intercepts. So how do we draw this though? Like, how do we actually draw this? So the start point is here, but does it go up or does it go down? What do you think? Again, the equation is 4 sine 2 times x plus pi on 6.
Does it go up?
Why does it go up?
Because it doesn't reach the amplitude yet, full.
It will go up, but that's not the reason. Sometimes it could go down. It depends on the shift. Think about what kind of shift is this. To the left or to the right?
To the left.
To the plus is to the left, right? Okay. And where does it start? Like where does the sine graph normally start?
The 0. No?
0. So this is a normal sine graph, right? If you shift it to the left, that means you shift it over here like so. So the starting point will be, right? Yeah. And then it has to go up first before it goes down. Because it only shifts like a little bit, right? So imagine that's the starting point, and then I shift this one over a little bit like that, see? Yeah, makes sense? So it has to go up first, but at which point does it reach 4, do you think? So we know that it has to go up all the way to 4, yeah? So once so I will draw out, like I will just quickly mark out this thing here, and then mark out the bottom here. So it has to go up to 4, and then it has to go down to this one, has to come down again, and then goes up here, and then goes past this one to 4, goes up down here, and then down again, and then up here, and then up here. Okay, see it's 4 cycles. All right, I'll highlight the first cycle in red, from here down here, and ends at the same point. And then the second cycle would be from here to here and back here. It's end somewhere random, right? It doesn't actually end at the maximum point, right? Because it has been shifted horizontally, but it's still 2 cycles. Right, so how do we determine what's the x-coordinate of the maximum here? I don't think they asked you for this one, but how do we determine it? Again, this is the equation.
You have to derive that. We have to derive that.
Yes, you can derive it and solve for when x equals to 0. Or you can analyze this. So this will be maximum when what? When the sign component of this, the sign factor is 1, right? It will reach a maximum, right? So you're basically solving, so for this point here, right? So solve for max is when sign of the equation 2x plus pi on 6 is equals to 1. Alright, and then you solve for x. Okay, does it make sense? Alright, similarly for the minimum, if you want to find the minimum point, you solve for when the sign component is equals to -1. Right, because then the function equals -4. Okay, and then you solve for the x value. You may not actually need to solve for all of that though, because remember, what's the difference between the x value of every major point? Right?
Is it
Sorry?
is it 1?
No. So this one you actually don't need to solve this. I'll just give you guys one last bit here. Remember when you basic sketch, there will be 5 points, right? Yeah, and then for the sine graph, you just connect, right? What's the difference between each major point? What's the difference here?
Is it the period divided by 4?
Yes, this is the period divided by 4. Okay, which means if you want, and we know that the point in the middle here has to be one of the major points, right? Because this is a sine graph, right? So the x-intercept, and there's no vertical translation, so the x-intercept is one of the major points. So to find the first major point, I would actually, so this is one way of doing it. Another way would actually just take -4 pi on 6, and then you subtract period, which is what? The period is pi. So subtract period over 4. Okay, a quarter period. And then you should be able to get the x coordinate of the very top point here. Alright, so quickly do that. That will be 12, so minus 2 pi, and then minus 3 pi over 12, so it'll be -5 pi over 12. Alright, if you solve it, you get -5 pi over 12 as the x coordinate of the top point here, which is about -2.5 pi over 6. Oh, no, I think you need to like. Oh wait, hang on. Sorry, that should be 8 pi over 12 minus 3. Sorry, -11 pi. Yeah, -11 pi over 12. Okay, so quite close to the negative pi value. But I don't think you're asked to do it in this question. Make sense? Okay, so please go back. Try this question. Okay, this question is one of the hardest ones I've seen in terms of simple familia for trigonometry, but it tests everything you need to know for trigonometry, almost everything. Okay, so go back, try this one, and then we'll continue next week.